So this is 1.4, measuring and classifying angles. We have to go through and basically do some basic understanding of angles and what entails them and how you name them and all that other stuff. So we have measuring and classifying angles. What an angle is two rays that share a common endpoint, provided that the two rays do not lie on the same line, because that's actually called a different type of thing. So here I have an example of an angle. We have two rays, ray AB and ray AC, that come together at a common endpoint. So the common endpoint of the two rays that make an angle, we call that the vertex. So the two rays are going to be called the sides of the angle. So in this figure here, we have A, point A is going to be the vertex, and then AB and AC's ray are going to be the sides, because again, they share that common point of A. You're going to name an angle. Remember, you name segments a certain way, you name lines a certain way, you name points and planes a certain way. Angles, you're going to be using, and this is key, 3 letters with the vertex in the middle or the vertex letter. That's depending on if the angle is only part of one angle, and we'll talk about that in a second. So what you are going to do is to basically take this part here. So the names of this angle could be threefold, actually, and I'm going to go through angle 1. That's 1 because the vertex is the name of the vertex letter, but you can only use the vertex letter if it's only part of one angle. So I'll show what that means in a few. So the other thing you can have is angle BAC, or you can have angle CAB, and the notation is this angle symbol here. You need to have the angle symbol to the side. Okay, so where are angles important? Just kind of an engineering standpoint of different angles that are associated with different types of golf clubs. The greater the angle, that means obviously the higher the pitch is going to be and the ball is going to go higher. The shorter or smaller the angle is, that basically means that the golf ball is going to go more straight. So there we go. So what I want you to do is I want you to go through the model example with me, and then I'm going to go through the guided example. So name the 3 angles in the diagram. So the first angle is going to be this angle right here, angle HIJ, or angle JIH. That's one angle. The second angle would be angle KIJ, or angle JIK, does not matter. The third angle is going to be angle HIK, because that's this part right here. That's that angle. You cannot just say angle I. The reason is for that, so this part here is incorrect. You do not want to do that, because I, even though it is the vertex and you name an angle with a vertex, I could be referring to this angle, or this entire angle right here. So you don't know which one it's referring to. That's why 3 letters is mainly the thing that you want to name this with. So those are your 3 possibilities. And what I want you to do is pause the video and go through the guided example and see if you can find which angles can be named with only using 1 letter, but name all the angles using 3 letters. Okay, so for this you have ABD, that's that first angle, or it could be DBA, but you have to make sure that the vertex is in the middle. You could also have DBC or CBD, because again the vertex has to be in the middle. You could also have ABC, which is this large angle here. You could have angle A, which is this angle here, and you can have angle D, which is this angle here. That's the way you actually label angles, and we'll get to that in a little bit. But I see 5 different angles that can be labeled. But you cannot use, for example, you can't just say angle B. This is incorrect, because angle B is part of 1, 2, and then the larger angle here. So you cannot use angle B. You have to use 3 letters with any angle that involves angle B, because the vertex is in the middle. All right, so now we're going to actually measure and classify angles. So to measure angles, degrees is the unit of measurement we will use to measure an angle. So a protractor is going to be used to measure angles, and we're going to use a protractor in this case. So we have, in this case, what you have to do is the protractor part that has the dot, you have to line it up with the vertex of the angle. And we are trying to find the measure of angle ABC. Let's say this is angle A, B, and C. So in this regard, we have you start from 0 and you go and see from here it increases by 10, 20, 30, 40, 50, 60, so on and so forth, all the way up to 105 degrees. So this angle right here measures 105 degrees. Where are angle measurements important? Well, if you've ever seen a tool that's called a miter saw, so this part here is called a miter saw. This actually cuts wood, pieces of wood on angles. So this is basically a big protractor with a very big cutting device. But there's 4 different types of angles that you can have. You can have an acute angle, which measures less than 90 degrees. So acute angles measure less than 90. You have a right angle, which measures exactly 90 degrees. And you have a obtuse angle, which measures greater than 90 degrees. If you have an angle that is a straight angle, we actually call that a straight line. It measures 180 degrees. We call that a straight angle. So here's what I would like you guys to do. We're going to skip that. I want you to measure and classify this angle. So take your protractor and measure the angle with your protractor. And I'm going to model this. So measuring the angle, we have ABC. So I put the protractor here and I measure. I got 10, 20, 30, 40, and about 45 degrees. So that means I would have a 45 degree acute angle because I'm asked to use the diagram to find the measure and classify it. So I did. 45 degrees is the measure, and classifying it is the acute angle. So same thing here. So measure it and then classify it. So you have to take your protractor and make sure that you orient it, because again, in this regard, we used to be going this way. So now we're going to be going the opposite way, which means we need to be going from here to here, which means we will be using the top numbers of the protractor. So we get up to, it looks like about 130 degrees. So let's see if that's correct. Absolutely, and it's obtuse because it measures greater than 90 degrees. Last but certainly, a couple more. So we have XYZ's angle. You could probably look at it and figure out that it is a straight angle, but just to prove, since it is a straight angle, it's 180 degrees. And this is the last one that's of the utmost importance because it has a few things of notation that's involved. So SRT, you line up your protractor. When you do that, you basically get a 90-degree angle, a right angle, and this is the symbol that is actually used for a right angle. So this is something that you need to make sure you know in a figure. If you see that kind of rectangular part that's in the corner of the angle, that means it measures 90 degrees. So we had something that was called the segment addition postulate. We now have something that's called the angle addition postulate. So if you know that P is some point that's on the interior of the angle, what you can basically say is that the 2 smaller angles, RSP and PST, will add together to give you the entire length of RST. So that's what this is basically saying. Intuitively, you guys probably remember if you had something, I don't know, like 15 degrees and this was like 30 degrees. You'd add them together, you get 45 degrees. Well, what this is basically showing is that you have 15 degrees plus the 30 degrees, and that can give you the 45 degrees. It's using the angle addition postulate, which you will be using in proofs later on in this course. Okay, so we're going to apply the angle addition postulate. So what we have is we have measure of angle WXZ is 145 degrees. You have to go based off of the labeling here. I know it doesn't look like 145 degrees, but you have to go based off of what I tell you in the notation. So if we know that that angle is 145 degrees, we're trying to find this angle here, and we're trying to find this angle here. So twofold. So the way you do this is you set up the angle addition postulate, and I know this is done in your notes. So here's the angle addition postulate. So once you add 145 degrees is equal to the two algebraic parts, you add those together. Simplify it, subtract the 7, and then divide by 6. You will get x is equal to 23. But what it's asking in the question is find the measure of wxy and the measure of yxz. So what you have to do is you have to plug this in to each one of the x values that you see. So with that said, when you do that, you get 56 degrees and you get 89 degrees as your respective answers. So what I'm asking you guys to do is, in the guided example, I give you that EFG is a right angle. So I'll start you off in the right foot here. That means that that's a right angle, and a right angle measures 90 degrees. Find EFH, which is this angle here, and find HFG, which is this angle here. You can go ahead and pause the video, or if you want to see how it's done, here we go. So the way you do this is set up the angle addition postulate, plug in what you know using substitution, and then solve like you normally would, solving for x, and I get x is equal to 16. But we need to find out what EFH is and HFG, so we have to plug it into each one of the parts. And so once we do that and figure out what x is, you plug it in, and we get 52 degrees and 38 degrees. So all we're doing, again, is using angle addition postulate, adding the two angles of 3x plus 4 and 2x plus 6 together, solving algebraically, and getting x is equal to 16. Once you do that, you're going to take this and plug it in to each one of the x's that you see to get your 52 degrees and 38 degrees as your answers. And that's it. So this is something we will do in class, but it's actually talking about this part here, which is definition of congruence. We did this with segments. So if you have two angles that are labeled the same way, we're going to go over this in a little bit more detail as well about how to label angles, but one arc mark to one arc mark means that the angles measures are the same. That means equal to. That means you can also say that the angles are congruent. So angle A is congruent to angle B. And just like in segments, if you have an angle bisector is a ray that divides an angle into two angles that are congruent. So anywhere you see bisector, that's going to be something where you're going to set two things equal to each other. So these, again, the definition of congruence is going to be used a lot when it comes to proofs. So here's my model example, guided and directed. So we have model example. If we know x, y, w is equal to 28 degrees and w, y, z, if they tell us in the directions here that YW bisects the angle, that means that these two angles are actually congruent. So if I know XYW here, XYW is 28 degrees, that means that this is 28 degrees because of this word here, it bisects. So that means if that's the case, that means we're trying to find XYZ, which is the entire angle. I just add the two together, and I get a 56 degrees to find the entire angle. The worked out form is worked out in your notes. This is another way of doing it, but you still get 56 degrees. Same deal here. We have XYZ is 51. So XYZ is the entire angle, but if we know that this bisects, that means we can do 51 divided by 2, which gives you 25.5 degrees. We know that this is 25.5 degrees. So the two angles are congruent because it's a bisector. And we're trying to find out what WYZ is. So WYZ, measure of angle WYZ, is equal to 25.5 degrees because of that angle bisector. The other way I can ask this is that if I tell you, again, that we know that YW bisects this, that means that these two algebraic expressions are going to be equal to each other, just like we did in segment congruence. So we have x plus 1 equals 2x minus 1. So I add or subtract, add 1 or subtract 1 from both sides, it doesn't matter. Subtract the x, and you get x is equal to 2. But we're trying to find w, y, z. So if I'm trying to define w, y, and there's supposed to be a z here, I don't know where it went. So if we're trying to find w, y, z, we're going to have to plug this in to each one of the x values, and I get 3. And here I should get 3, which I do. 2 times 2 is 4, minus 1, which gives me 3, and it's degrees as well. And that means we get w, y, z, so the measure of angle w, y, z is 3 degrees. And that's it.